Hello, I'm here to provide help on programming exercise 2 for the CST 235 class. This programming exercise is a big one. It's going to grow into the benchmark exercise for our class. So this is a tutorial to walk you through my approach on writing the game API. So over in Eclipse on the right here, I have my game driver. I copied the Uno game milestone 4 actually. That a student last semester submitted it, and I greatly simplified it. Notice all the supporting classes are gone over here, but the game driver I left untouched. I wanted to make it look the same from the outside world, from main, the game driver, that it did before, while I greatly simplified the internals. Let's see what this program does. So it prints two numbers, and this one grows up faster, then becomes 0, and then we have another number here that grows up. Every time I run it, there's a different number of numbers that print. So let's take a look at what's happening inside this logic here. So in the game itself, you can see greatly simplified. I have a random number generator, and I set it to limit. So this is going to be between 1 and 20. So that's how many times this loop will run, between 1 and 20. I have a variable here called add and a variable here called multiply. And this simply adds itself to itself every time through the loop, and multiply multiplies itself every time through the loop, and then they print out here. Two numbers being printed out, and you can see the multiply. And then once the multiply reaches this value here, it multiplies by itself and it loops back to 0, and then thereafter is always 0. Of course, because 0 times 0. And this adder one lasts longer, and now you can see why this is behaving as it does. Pretty simple. Now, the overall goal of turning something into an API is actually to separate its logic from any kind of direct user interface tie. So the API returns information to the caller. Its client is other computer code that eventually make the data transform it into something that becomes the UI. As we can see here, this is written just like that you've written your Uno game, and like all these other milestone applications, how students approach this, and that is you have some kind of driving logic, a loop that runs until the game is over, until a winner has been declared. In this case, I have a loop that runs until this random number generator reaches its limit, but it's just a simplified version of that same overall pattern. The logic plus the UI are mixed together. Now, if I want to turn this into an API, that is, I have something relatively complex like the Uno game, and I want to put it on a server and then have a client be able to connect to that server and get game results, then I need to separate out the game logic from the direct attachment to the user interface. So I'm going to follow the requirements in this exercise exactly as I do this. I'm going to copy the game class because that's where my logic is. So Control C, Control V, and then it asks me for the name. I want to call it Uno Game API, just to match all the naming conventions that are required. I bring the file over. Of course, it's the same file. Eclipse has handily renamed the class name for me because it's a public class, and I gave it the file name, so Eclipse has done that for me. But otherwise, of course, it's not going to touch the internals of that. That's for us to do. So the first line of the first requirement here, right in the assignment, make a private constructor. So that's what I'll do. And the notion of the private constructor is, now the outside world, code outside this class, can't make instances of the class, can't make objects of it. Therefore, to be useful, right, because right now, if you can't make objects out of this class and there's no static methods in it, it can't be used at all. It's useless. So you need a factory method, a method that gives you the ability to control instantiations of the object. That's what factory methods do. Constructors don't give you that control. If you have a public constructor, any code can call new and make an instance of the object. If you don't need managed object creation, you don't need a constructor. But sometimes you do want managed object creation, and this is a case of it, the Uno Game API. So the factory class is what this paragraph talks about here. So we'll follow this code example. So I'm going to follow it exactly. I'm going to have this. I'm going to have a hash map here. Let's see if I can copy this code here so I won't have to type it again. So I have my hash map copied in. I brought in the package. I already have my private constructor, so I'm going to copy this code right here. Should have copied just the whole thing. I'm going to leave game in place and paste these methods over here, which are just method shells right now. I hit Control-Shift-F. All right, let's implement getGame now. So I have the comments use getGame as a key in the hash map. If getGame is not found, create a new game and add it. So I'm going to do exactly implement what I have in comments here. So I'm actually providing you a lot of guidance in the write-up here. Just read it closely and you'll see. So I have pre-written code and I'm just going to paste it in here and we'll go through it. I have more comments now than code. I create a game. I do get on the hash map, get game. And if that is null, there's no game found by this key. Essentially, the game name is the key here into the hash map. If I don't find it, then I create a new Uno game. I can use the private constructor because I'm inside the club here, inside the class where the private constructor is held. And then I immediately store the game away in the hash map. So the next time this is called with the same name, the same game object will be returned. And that's really important to understand this particular factory. Not all factories work this way, but this factory says, give me a key and I'll give you an object and I promise I'll return the same object every time. This is a lot like the logging code. I modeled it after that, the Java standard library for logging that we used, how you have a static constructor there and you pass it a string which acts as a key, and every time you pass that same key you get the same logging object back. This with the same key will get the same object back. You can pass as many keys as you want and get a new game, but with the same key, same game will come back to you via this factory method. So now the logic becomes I want to expose in turn what the internal logic that the UI needs, or not the internal logic. What's the data that the UI needs? And so I need to analyze this. In the Uno game, it's going to be more complicated. It's a bigger task, but I have really two pieces of information that I need to expose: add and multiply, because that's what the UI needs. There's some other internal logic, state variables that matter. This loop counter is one of them, and the limit is another one. But since those aren't used in the user interface, we don't need to expose those in what's going to become the turn method. The turn class. Let's turn our attention to this empty constructor. And what logic is appropriate here? Well, I'll argue that as we work essentially taking apart the logic that we find in between these two curly braces, we're refactoring this logic. Try not to break it. Well, we refactor, but we're going to move the pieces of it apart so we can separate out and tease out the user interface elements from the internal logic. So I would argue that this logic here, let me copy this line of code or cut it and put it in the constructor. Then finally, I need to make this final limit a variable at the object level and set it in the constructor. So let's discuss this logic now. Final stays in protect. That's perfectly fine. It makes it a constant, and it makes it a constant that the constructor can set, and nobody else. So the compiler allows it to be touched here, it has to be touched there, and then that limit is set for that object. So every time I have a new Uno GameAPI object, they'll all have their own internal limit because the logic remains intact of using a random number generator. So there'll be a unique limit set in each one of the Uno GameAPI objects. The next thing we'll think about is this loop counter here. So the loop counter can't remain internal like it is either, because the next turn logic is going to say, is the loop counter reached the limit? Just like the internal logic does here, but these need to be exposed. Therefore, my loop counter needs to be at the object level itself. And I think at the object level, it needs to have a more meaningful name than I. I is an obvious loop counter when it's in a for loop, but not a good name for it at a class level. So I'll do the logical constructor thing. We know that it'll be initialized to 0, but just to make the constructor formally correct, I'm going to set the loop counter to 0. Of course, it can't be a final because it's going to be a counter. So next turn. So what would next turn do? It'll increment loop counter if loop counter less than limit loop counter gets incremented. That's it. And then it'll say return true, of course. We need, I should have put curly braces to begin with. All right, so now our logic is pretty simple, pretty plain. We have a limit here, object level variable, and a counter, object level variable as well, not a constant. So loop counter less than that. We increment the loop counter, and then we return true, and otherwise we return false, that there's not a next turn available. Next, we'll look at what turn needs to expose what's happening inside the game. I'll click here, and Eclipse offers us this, so we'll do that. Just accept the logic here. So what does turn need? Let's take a look. It needs to have add and multiply. And add and mult. See, those two need to be at the class level. They need to maintain their state, by the way, because each time through they're being modified by their own internal rules. So every time you call next turn and get turn, those need to be modified as well. They have to be state variables that are at the object level, therefore. These are state variables, but they're local variables. We're promoting them up. And I could initialize these in the constructor as well, but I'll leave it just for simplicity's sake. I'll just leave it like it is. So we've already analyzed this, and we know that turn needs to have add and mult as well. So I'm going to copy these from here, bring them over to turn. I should have declared them privately in the other class as well. I'll fix that. We won't set them to initial values. I will use Eclipse to generate a constructor. Both. Good, I have my constructor. Now let's go back to our API here, and we'll turn our attention to getTurn. Now that we have the turn class, we can create an object out of it, and all we have to do is return new turn, use the constructor we just created to set the add and multiply values. And now we have the ability to return the information that the caller needs. Notice there's actually 4 internal state variables for this very simple code. What's the limit? What's the loop counter? What's add and mult? Maybe loop counter. I'm thinking about the name of this now. Let's rename this. I'm going to try refactoring. Sometimes this goes wrong. I'm going to call it call counter. When I hit enter there, it changes everything in refactoring. It's a nice way to change a variable. Because it's, I figured loop counter, this doesn't necessarily know it's being called in a loop. It probably is, but call counter is better, and then limit that because we know we're being called this many times. In any event, the UI doesn't need it, so we don't expose it in terms of what we export into turn via this constructor here. Now, if I've done everything correctly, and I haven't changed any of the names, I should be able to copy my game driver. This is what you have to do, by the way. This test driver is required. Make sure you write your API exactly as specified. Control C, copy it here. Now, if I've done my work properly, I should be able to paste this in and run this. Looks like we have an error. Let's fix that. In my copy and paste haste, I obliterated the class it was in, so let's do that more carefully. Hit Control Shift F and neatify it up. Okay, let's fix up our remaining errors. I need to, of course, import ArrayList as a package, and I need to write the print turn method. We'll do that next. Eclipse can also help here. I'll do this. Create method. Of course, it can't write the logic, but it knows how to follow the pattern. I want to print this out just like I did before, so I'm going to copy this over to Game Driver. And then I will, let's go over to turn. I need getters. Go back now to Game Driver and make this use the getters. Now we'll run this. Now let's take a look at it first before we run it. Now that we have this as an API and we've separated the logic out from the UI, and I haven't run it at all yet, so I don't know what's going to happen. This is the previous run of the simple version. I have the GameAPI and I put it in an array list, and I'm creating an array list of them, and I'm also having game over flags. This is exactly from here. So I'm setting up a game count here, also a constant here. So I really established 5 games. That are these simple loop counters. They're not gonna end at the same time. Remember, their limits are all random number generators, so some of them are going to end before others. So this loops and creates both the counters, adding the flags to say the games are not over false, and then adding the game to an array list of games. And this will run till all games are over. This is the method here that I've also provided you in the write-up to say, when all flags are found to be true, then return true, all games are over. So this will run the game count, fetching the game using the factory method. So we use the factory method. We know that the factory method is going to create at this time, but that's transparent to us in the UI. We just say get game and give it a key. The game is created at this point and added to the array list internally inside of this, but it also has its own management of its own management, and that's added to this array list, all encapsulated in those objects. And then when we call the factory again, we get that same game back. So we're driving this through the loop, and we're asking get game to get the current game that we want to play. And so let's run this finally, and we can see what's happened here. Of course, it's very simple, but the logic pattern here, we do this and this. So all of them are running right now, behaving strangely. Let me see if I can debug this. It doesn't look like I'm maintaining the values here. Hold on. Oh yeah, I wasn't doing anything to add and multiply. I was just... So next turn, I can make next term do this. Let's do that. Let's prep it in next turn. Get turn could do it as well, but I'm going to put it in next turn. The actual logic to, that's not what I want to do. There we go. Now we should see a correct report, and we see this. So remember, we're running 5 games, and you can see they're interspersed. You can fix up the printout. So 4 is over. It's done with its loop, and every time it's called, it's going to report. It's going to report that. You should do that too. So it's stable. Basically, it remembers the game is over and it won't iterate over itself. But you can see there's 0 through 4 games with different loop counters, and successively they're finding that they're going to run out. But once they all run out, they're all done and the entire game is over. So I hope you find this useful in separating out the much more complex task of separating out the logic from the UI in the actual Uno game, but I tried to follow the pattern as closely as I could. Good luck this weekend.